Alright class, welcome to our lesson for the week. I hope you are doing well and staying healthy. This week we're going to look at patterns. We will see how patterns we can find can be represented through familiar formulas. Let's take a look at these first few examples. You can see how this sequence goes up by 1 each time. You can see it goes plus 1, plus 1, plus 1 every time, right? So because we're adding 1 every time, then it's pretty easy to see that if we want the 10th term, that 10th term is actually just going to be the value of 10. If we want the 50th term, then, well, that's just going to be 50. If we want the nth term, then that's just going to be n. Pretty simple. For the next one, if we have, notice how each of these are going up by adding 2 every time, plus 2, plus 2, plus 2. Right, so if you just think about how, okay, well maybe this is like our first term. Let's say n is 1, here n is 3, so here n is 4. So you can just imagine here that basically what we're doing is we're multiplying 2 by the term number. So in this case, if we want that 10th term, we'd be multiplying 2 times 10, or that's going to give us 20. If we want that 50th term, then we're going to go to the 50th term, but everything just gets multiplied by 2. So here we're going to get 100. So therefore, if we want the nth term, then that just means we're going to have 2n. Okay. All right, find the formula for the given sequence. This one's a little bit different. We're going 10, and then it looks like what we're doing is we're adding 7 here. 17 to 24, again we're adding 7. So just like the previous two, it looks like you're always adding the same number. Now if you notice, every time you're adding the same number, it looks like these are basically creating like a linear pattern. And with that linear pattern, we know that the pattern is that we have some kind of constant rate of change. And you've seen that before, right? In Algebra 1, constant rate of change. That's giving us an idea where maybe we can work with y equals mx plus b, a linear pattern. So if we're always adding 7 every time, you've seen that before, that's kind of like your slope. So you're saying 7, and then, well, if you have your term number, like n is 1, n is 2, n is 3, then it's 7 times whatever that term number is, let's call it n. And then if it needs to work for the first term, then you want to make sure you get the value of 10. Well, 7 times 1 is 7, and then plus 3 would give you 10. 7 times 2 is 14, plus 3 will give you 17. So it looks like that's going to be our pattern then, 7n plus 3. Let's try the next one. From 37 to 29, what is that? That's subtract 8 each time. 29 to 21, again, subtract 8. So if we're thinking about this again, where this is our first term, our second term, our third term, then because you're always subtracting 8, subtracting 8, subtracting 8, you've got that linear pattern going. So we know that we're going to have some kind of negative 8, that's our slope, times n. And so negative 8 times 1 is negative 8. How are we going to get that 37? We'll have to add 45, right? So our pattern is going to be negative 8n plus 45. Okay. Alright, let's go on. There we go. Alright, so we got 2, 5, 8, and so on and so on. It says graph it as points. So let's go ahead and do that. Let's draw our xy coordinate plane. And here we have 1, 2, 3. These are our term numbers. This is our term number. Term 1, term 2, terms 3. And then this will be our actual value. So we'll have 2, 3, 4, 5, 6, 7, 8. Right, so we have 2, 3, 4, 5, and 8. Okay, so when we have term 1, that's the value of 2. Term 2 is the value of 5, and term 3 is the value of 8. Okay. Well, if you notice, every time you go from term to term, it looks like we're adding 3 each time. So again, we've kind of got that linear pattern going on there. It forms a line. And so you know that the nth term is basically going to be represented by 3, the slope, times n, the term number. And then, well, if you want that value of 2, you're going to have to subtract 1, right? 3 minus 1 will give us 2. So b, find the equation of the line. Well, that's easy. Just turn the n into an x variable. So therefore, y is equal to 3x minus 1. Okay. Now, notice here, I have these points, but I'm not going to connect them. Because imagine, if you were to connect them, then that would mean that you can actually have a term number of like 1.1 or 1.5, but we really don't. This sequence actually is the way it is. It's 2, 5, 8, and so on. So therefore, do not connect lines. Do not connect. What this is it is just a series of discrete points. Okay, these are just discrete points, so just bear in mind that. Okay, all right, let's go on to the last question here. Let's see, what are we doing here? What term is 259? So it goes dot, dot, dot. We're going to get a bunch of numbers, and then eventually we're going to get to 259. Well, here's our first term, here's our second term, and so on. What are we doing every time? It looks like we're adding 6 each time, right? To get to the next sequence. So that means in terms of our pattern, we have 6, which is our slope, times the term number. 6 times 1 will give us 6. How are we going to get that 7? Well, that just means plus 1. There is our sequence, 6n plus 1. Now remember that we need to have that value actually be 259. So 6n plus 1 equals 259. Okay, subtract 1, you get 258, divided by 6, and n is 43. So that means that we're going to have this 259 is basically the 43rd term then. Okay? All right, let's go on to the next page. So, let's see here. Is that the top? Nope, that's not the top. Let's go to the top. All right, number 7. 1, 2, 4, 8. Let's see. Add 1. Uh-oh, that's not add 1. That's add 2. And then add 4. This is not a linear pattern. Not linear. How do we know that? Because it's not a constant rate of change. Okay? All right. Well, what is it then? Well, let's just take a look. We know when it comes to these kinds of problems, I like to build a table based on the term number and the actual value. The term number just means it looks like we have 1, 2, 3, 4 terms, and then our value is actually 1, 2, 4, and 8. Now, how are we getting to these numbers? Well, you can see that they're actually always being multiplied. They're being doubled every time. So times 2, times 2, times 2. In essence, what you're doing is repeated multiplication. So this is actually just the value of 1, but then you take that 1 and multiply it by 2. You take that value, 1 times 2, and multiply it by 2. You take that value, 1 times 2 times 2, and what do? Multiply it by 2. See that? You get repeated multiplication. Okay. So let's find a formula for this then. If we don't have a linear formula for it, maybe there is something that these all have in common. Okay. Notice that they all have 1. And then what we're doing is we're multiplying it by 2. Then times 2 again. Then times 2 again. Looks like here we multiply by 2 one time. The second term has 2 one time. The third term has 2 two times. The fourth term has 2 3 times. Okay? Fourth term has 3 2's. Third term has 2 2's. Second term has 1 2. It sounds like what we have is always 1 less than the number of 2's. Maybe it would look like this. You multiply by 2 1 less number of times than the actual term number. Maybe that might be our formula. Let's do some more examples where we see some similar cases, and maybe it'll just be a little bit clearer how we get those formulas. Okay? So just like we did before, this definitely does not look linear. We're not adding 4 every time. So just like we did before, I'm going to go ahead and create a table with term number and value. Okay? I have 4 terms. So 1, 2, 3, 4. And my values are 2, 6, 18, and 54. All right. Well, how do we get 2? Well, that's just 2. How do we get 6? That's 2 times 3. How do we get 18? That's 6 times 3, right? Or in other words, 2 times 3, which was 6, and then times 3 again. How do we get 54? Well, that's the 18. 2 times 3 times 3, and 18, you got it, times 3 also gives you 54. So it looks like, again, we're getting that repeated multiplication. Those 3's are multiplying 1 more each time. But look, this is what always remains consistent. you always have a 2 in there, and you multiply that by, look, you always are multiplying it by 3. How many 3's do you have? You have 1 3 in the second term, 2 3's in the third term, 3 3's in the fourth term, or basically you always have 1 less 3 than the actual term number. So that would be our sequence in this case here. Okay? Number 9. Notice here, we're going 5 to 20, 20 to 80, 80 to 320. Hopefully you're starting to see that repeated multiplication again. You have to multiply by 4 every time. Okay? So in terms of building our table, we say term number versus the value, and then we have 4 terms, and we have 5. 5 times 4 is giving us 20. 5 times 4 is 20, times another 4 gives us 80. 5 times 4 times 4, that's going to give us 80 times 4, that's 320 there. So what you see is the same value, it's the 5 multiplied by repeated 4's. Notice how many 4's you have. In the second term, there's only 1 4. In the third term, there's only 2 4's. In the fourth term, there's only 3 4's. So you always have 1 less 4 than the actual term number. Okay? So the idea here that we're doing when we have repeated multiplication, we call these geometric sequences. Geometric sequences is the idea that you have repeated multiplication. Okay? Or contrast that with, I'm going to go back to the previous page, everything that we've done here where we had linear patterns, these are called arithmetic, there's an H in there, metic sequences. And arithmetic sequences are in the form of a line, a linear equation, y equals mx plus b. So just keep in mind those two kinds of sequences. Arithmetic is linear, and on the other end, geometric is repeated multiplication, or you can kind of think of that almost like exponential, right? All right, so let's take a look at number 10. What is that? Is that linear? Is it, or do we call it, is it arithmetic? Is it geometric? Or is it neither? Well, if we look at the term number versus its value, let's take a look at these values. We have 1, 2, 3, 4, and the first term is 1, then we have 4, then we have 9, then we have 16. Arithmetic would mean, let's add 3. Add 3, no, 4 plus 3 doesn't give us 9. It's definitely not arithmetic. Geometric, let's see. 1 times 4, repeated multiplication. Times 4, no, 4 times 4 doesn't give us 9. It's neither geometric nor arithmetic. This is actually going to be a neither sequence. Find the formula. Oh, we haven't done that. Well, you can still just work it out. Just think about how you get these numbers. 1 is 1 times 1. 4 is 2 times 2. 9 is 3 times 3. 16 is 4 times 4. Hopefully you see this pattern where you're just multiplying the number by itself. Oh, look at these term numbers. 1, 2, 3, 4. 1, 2, 3, 4. You're basically just taking the term number and squaring it. That's it. Okay. All right, number 11. If the following sequence is arithmetic, so therefore we know it's linear, then find the missing numbers. So we know we're going to have to add the same number, add the same number, and add the same number to get to 39. How many times have we added? 1, 2, 3, 4. So we have 4 common differences. Let's call that 4D. 4 common differences. And what you did was you had to start off at the value of 3. 4D plus the 3 that you started with will give you the value of 39. In solving this, we'll be able to get the actual common difference. We'll see that 4D is equal to 36, or the common difference then is just 9. So what we're saying is we're adding 9 every time, like that. Okay? So if we're adding 9 every time, then that just means that this is 12, 21, and 30, like that. Okay? Find the missing numbers. We did it, check. And find the formula. If the common difference is 9, then that means that's our slope, 9 times n, And then, let's see, how did we get 3? Minus 6. If we have the first term, 9 times 1 is 9. Minus 6 will give us that value of 3. Alright, and the last one on this page here. Number 12. If the following sequence is geometric, find the missing terms and formula. So, just do this the same way. Remember, it's geometric, which means what we have to do is multiply by some amount every time. Repeated multiplication until we get to that value of 3072. 1, 2, 3, 4, 5 times? We have to multiply something 5 times. Let's say because we're multiplying something, it's going to be multiplied by some common ratio. Let's call that r. So if we multiply r 5 times, r times r times r times r times r, then that's saying r to the 5th power. And if you multiply that by the 3, it's really 3 times r times r times r times r times r. It's 3 times r 5 times is equal to the value of 3072. Solving for r, so r to the 5th is 3022 is divided by 3 will be 1024. Take that to the 5th root, right? So we 5th root both sides. And when we do that, remember, because it's an odd root, it is just the positive number. And so the 5th root of 1024 is just 4. That's our common ratio. So we're saying let's multiply by 4 every time. Okay? So if we multiply by 4, then we'll get what? 3 times 4, 12, 48, 192, and 768. Okay? Alright, so there's our numbers, and then the formula therefore is going to say, well, we start with 3 and multiply that by the ratio, which is 4. And how many 4s do we have to multiply by? Well, you're multiplying it by, remember, it's always that formula of to the n minus 1, just like that. Okay, so that'll conclude our lesson for today. Best of luck doing the homework. I'll pass out the homework online. And if you have any questions, don't hesitate to give me a chat on Google Hangouts. Alright, have a good week, guys.